Hello everyone, please let me know if I am audible to you all or not. Please write in the chat. Hello everyone, please write in the chat whether I am audible or not. Okay, thank you. Okay, thanks. Okay, welcome everybody to the series of Google Kickstart. My name is Puneet Kansal and I will cover various questions from previous rounds of the Google Kickstart actually in this series. Please you people please also share what is your expectation from this session, what you are expecting, what you will get from this session. Please share in the live chat, then I will proceed. Actually in this session, in this series we are going to make a complete series on Kickstart, and we will cover various previous round questions of Google Kickstart. In this session itself we will cover round A questions, and we will actually try to analyze the questions, their complexity, and then we will see how their code is working, and we will go through various analysis. Maybe the problem can be solved in order of n time, or maybe in log n time, and maybe in cosine time. So we will check all we will try to find out we will try to solve the problem in different way. The same questions, actually I pick all the questions from round A, and we will cover all of them one by one. Let me start. Let me take the first problem, that is the k-goodness string. This is the first problem of the round A in Google Kickstart. Let me show you this problem actually on the Google Kickstart page itself. Let me show you. So this is the round A Google Kickstart, and this is the first problem actually I am taking. Let me open it, and this is the problem, and this is the problem statement. I am not going to read this complete problem statement for you. Actually I just simplified this complete problem statement in my PPT itself. So I will go to my PPT, and let me I will explain the problem statement here itself. Everything whatever was written on that page, on Google Kickstart page, I just summarized the problem into 1 or 2 lines, and that is actually the problem what they are asking. Let's see what is the problem. What is the k-goodness string problem? Let me read this statement. Input a string of length n. We need to take a string of length n and convert it into a string with a goodness score of exactly k size. One thing is clear, we need to take a string as input, and we have some new term here, goodness score. On the basis of this goodness score, we need to find out this goodness score in our string. What this goodness score is? Let's see first what this goodness score is. The goodness score of a string defines the number of index I such that this condition, this one is very important, this condition satisfy actually. So if this condition is satisfying, means we have one goodness score. If this condition is satisfying, many times, we have many goodness score. Okay, let me explain the same statement with one example. So here we have our string. This is our input string C A B C. Okay, and these are the indexes 1, 2, 3. I have started the indexes because that is mentioned in the question itself. The string is starting from 1, not from 0. Okay, and what we need to find out, that we need to take this string as input, and we need to find out some goodness score. What goodness score is? We will match first character in the string, input string, with the last character. First character with the last one. Okay, first one is C and last one is also C. According to this condition, we need to match. If they are not matching, according to this condition, what is given in the question, if they are not matching, then we will get one goodness score. But in this case, C and C are matching, so we get 0 goodness score. Okay. Similarly, we need to match this second character with the second last character, actually second character with the second last character in the string. Okay, so if we are matching A and B, are they matching? No, they are not matching, and they are satisfying this condition. Actually, I am just explaining, okay, what this condition is doing here with the help of this example. This condition is checking for all the characters present in the string, whether they are matching or not. If they are not matching, then that's good. With this condition is satisfied, and we get one goodness score. Okay, if they are not matching, but if they are matching, then we get 0 goodness score. That's it. Okay, and we need to count this goodness score itself in this question. Okay, you can read the main headline also, K goodness string. Okay, so here A and B are not matching, so goodness score will be 1 for these characters. Now I will match third character with the third last character, which is this one in the string, and if they are not matching, so we will add one more goodness score. So for this string I can say, okay, 1 plus 1 plus 0, goodness score is 2. Goodness score is 2, and according to our question, we need to convert our this string, input string, into K goodness score. Okay, I am repeating the question again. We will be given a string of length n as input, and we need to convert that string in K goodness score, exactly K goodness score. Let's suppose K value is 3. Means 3 characters must not match with each other. Here in this string, first and last, and we need to match in this way: first and last, second and second last, third and third last. We need to match in this way according to this condition. Okay, so here in this case, if user is asking for 3 goodness score, okay, for K value as 3, if that is asking for 3 goodness score, we need to convert this string. We need to modify it somehow that we get 3 goodness score from here, and we can get that actually by replacing this C with any other alphabet than C. If I am replace this with A, then A and C are not matching. If they are not matching, then we will get goodness score 1. So total goodness score will be 3. Okay, so that is required by the user. So simple, user will give a string, and that will ask for a string to convert the input string into a string of K goodness score, exactly K goodness score. Okay, that what we need to do. Okay, so this is the problem statement of the first problem in the Kickstart round A. Let's now solve this problem. Okay, to solve this problem, we are assuming that there are X index in our string S such that this condition is satisfying. Means we are assuming that, okay, there are some index on which there are some characters on which this condition is satisfying. Okay, And if this is the case, definitely there will be some characters that will be not matching. First maybe not matching with the last one, second maybe not matching with the second last, and so on, maybe. So if this value can be 0 also, maybe everybody is matching. Okay, so there will be some value of x, either 0 or any value. Okay, based upon this, actually we can divide our problem into 3 cases. We can divide our problem into 3 cases: case 1, case 2, case 3. What these 3 cases are? Here in first case, see, this k is given in the input. Actually we know this thing, this is given in input. User is asking that, okay, he wants k goodness score, but we are saying that we are assuming that we have x goodness score, and user is asking k goodness score, and they are matching. That may be possibility. First case may be that both are matching. What user want, that is exactly same as what we already have. Okay, so this case may occur, and the second case may be user want k goodness score and we have x goodness score, but already available goodness score is greater than the required goodness score. For example, x value is 5, means already goodness score is 5, but required goodness score is, let's suppose, 2. Required goodness score is, let's suppose, 2. X is greater than 2, 5 is greater than 2. So in this case also we need to perform some operations so that we get 2 goodness score, because according to problem statement, user want exactly I am using word exactly k. User want exactly k goodness score, not 5. Even 5 is more than 2, but he don't want, he want exactly 2 goodness score. Okay, so this will be the second case. And in the third case, we are taking like, okay, k is the required goodness score and x is the given already available goodness score. And let's suppose, okay, let me take an example. X value is 2 and k value must be greater than x. Let's suppose, okay, let's suppose 4. K value is 4. So we already have two characters in our string which are not matching, but we want 4 characters in our string which should not match actually. Okay, so actually 4 is greater than 2. So so these are 3 different cases that may occur that we need to work upon to get the solution. Actually we need to make these three cases, and based upon these 3 cases actually we can solve our problem. Okay, before I solve this problem, please you people write the solution for this question in the chat. Okay, this is for you people. You need to find minimum number of change operations required. For all the cases you need to answer this question. You need to tell, okay, how many minimum number of operations or change operation, how many character you need to change in case 1, how many character you need to change in case 2, how many character you need to change in case 3 if case 3 occur. Okay, please you people write in the chat. Meanwhile, let me rub this board. Please try this one and write in the chat. Many of you I know must already will be knowing about these problems. We will study this problem in little bit more detail. We will analyze them. Okay, we will cover this problem in more detail, so that okay, we can understand that, okay, how we can solve these type of problems. Okay, in the future, how these type of problems, what should be our approach actually. Okay, so this series is actually to develop that thing in you. Okay, how you have to think about these problems, we have to solve these problems. Okay, please anybody please write in the chat for case 1, how many minimum number of change operations, means how many characters I need to change if first case occur. Means here k is the required goodness score and x is already available. We are assuming that okay, x is the already present goodness score of the string. Okay, so this is the present goodness score, the string which we have taken input, that is having x goodness score, and k is the required goodness score. According to case 1, both are same. Then how many change operation we need in this case? Anybody? In case 1, no operation. Very good. Okay, very good. In case 1, we need actually 0 operation. Very good. This is actually Mohammed Nehat. And in case 2, somebody given that okay, x minus k. Yes, because x is greater than k, so x minus k change operations are required. Okay, and in case 3, let me see if somebody gives the answer. Yes, again Nihal have given the answer, that is k minus, he has written k minus x. Okay, that is right. Okay, so let me share the solution with you. Let me erase the board. Okay, so these are the solution for this question for all these cases actually. So 0 change operation we required here required x minus k, and you have given k minus x. I just write okay, I just take the absolute of x minus k itself. Okay, so that I can put the same thing in our code. Okay, okay. So this is the, on this basis actually we are going to solve our problem actually. Okay, this problem. Okay, let's move on. Okay, let's find out the complexity. Let's find out the complexity of our problem. So to find out the complexity, I need to match first factor with the last one, second with the second last, third with the third last, and so on. Okay, we need to match like this. So can you people tell me, to match first factor with the last one, second with the second last, third with the third last, and so on, how many time I need to rotate the loop for that? I need to check this condition every time. Okay, to check this condition, how many times I need to rotate the loop so that I can match first with the last, second with the second last, third with the third last, and so on. So how many times we need to rotate the loop? Please mention in the chat. Yes, anybody please. Anybody please tell me. We need to match first with the last one, first character with the last one, second character with the second last. According to this condition actually, they should not be matched. Okay, if we want goodness score, we want to increase our goodness score. So I am simply asking, okay, I just want to match. Let me give you an example. A, B, C, D, E, F, G, H. I am matching A with H, B with G, C with F, D with E. So the length of the string is 1, 2, 3, 4, 5, 6, 7, 8. So here n value, this n is 8. Okay. Then how many time I need to rotate the loop? How many time I need to rotate the loop so that I can match all of them for this condition? So order of n by 2. Very good. Order of n by 2. Very good. Or you can write actually order of n if we want to find out the complexity of this algorithm. Okay, let's take little bit more, let's go a little bit more deep in this. Let me rub the board. Okay, now my question is this: how many comparisons and swap operations you need to perform for all of these three cases, for first case, second case, and third case? I know you people know all these things. Please share this detail so that other people who are beginner here, they can also learn from it. Please share whatever you know about these questions. You can solve these questions. Please share the answer in the chat. Okay, we need to find out how many comparisons and swap operations we need to perform. You need to tell for case 1, case 2, and case 3. And we already know x x number of index satisfy this condition, already satisfying this condition. X we know already is number of index which are satisfying this condition already, and k is the needed. Okay, so how many comparison? First of all, comparison. Okay, so how many comparison you need to perform for in case 1? If required goodness score is same as the already available goodness score. So in the first case, anybody please? Okay, comparison n by 2 and swap 0 time. So for this case 1, we need to perform n by 2, even though they are matching, but we need to check, we need to perform the comparison. Until we will not compare them, how we will get that okay we are in case 1, how we will reach there, how we will know that okay we are in case 1, unless we will not compare n by 2 elements. Very good. So in this case also you need to compare n by 2, in this case also n by 2, and you have already mentioned, very good, we never need to perform any swap operations. Swap operations are 0 because we are just verifying. We are not asked in this question to replace. Okay, we never need to replace like this A, B, C, D. A. We never need to replace this A and A. We never need to replace this A with B. They are just simply asking okay how many changes are required to reach here to get this goodness score. So we never need to perform any swap operation there. Okay, we never need to perform. We can simply say that okay this is not counting in the goodness score. So if you want to count it in goodness score, you can simply count it. You can take a counter, you can take a variable, and you can count it. That's it. You never need to perform. Some people perform in the exam also this swap operation. They are just changing this value with some value. Never need to perform. Okay, let's move on. So the complexity of this algorithm is actually order of n. Okay, again let's further move in the complexity of same problem k goodness string. I have little bit modified the statement, actually problem statement. This is the same problem statement but modified here. Earlier there was exactly mentioned here, exactly word was mentioned here, but now minimum is mentioned here. So can you people tell me now what will be the time complexity if the problems look like this? Please try it, please share it. So here anybody please? Okay, here see we need minimum k length as a goodness string. Okay, we need minimum this one. Okay, let's suppose this is our string, this is n by 2. Okay, we are performing actually n by 2 operations. This is the half of that string. Okay, we need only k, minimum at least k character should not match here. So k operations we need to perform. Okay, after that even the goodness score is more than k, even the goodness score is more than k, that there is no problem. Okay, but minimum should be k. So I can stop here itself at the k. I can stop here itself. I never need to go up to n by 2. Why I do not need to go up to n by 2? Because I am looking for minimum only. Okay, minimum are satisfying. There can be more than that, no problem. Goodness score can be more than that. So if something is matching here in this area, no problem. Okay, because we are looking for minimum, and minimum is can be checked in this area itself. Okay, so the complexity is order of k for this modified statement. Okay, let's move on. So I have shared the code. I am not sharing the complete code here. I am sharing what is the important part of the code. We know that we need to rotate n by 2 times. You have already told me that okay, we need to rotate n by 2 times, and we are checking this condition. This condition is already given in the question itself. We are checking this condition. If this condition is satisfying, then we are incrementing the counter. That's it. And after that, we are just printing this counter. So this is actually that's it. This is k goodness string problem. You can see it here at the kickstart also. So actually I am just showing some easy code to you. Here is the same this thing actually I copied from here and copy in my slide. Okay, so this is n by 2 time we are rotating and checking this condition and adding the score or counting. And what about this loop, outer loop? This outer loop is actually just checking the test cases, how many test cases we want to go for. T is the number of test cases, and this loop is going for how many test cases, and that's it. Okay, let's move on. Let's take another problem, second problem, L-shaped plots. This is second problem of round A actually. Again, actually I have reduce the problem size. See here, you can see the problem size is, this is the actual problem. So this is the problem statement. Okay, different cases. I just reduce the same problem in 1 or 2 lines actually, so that we can understand it easily for the people who are new here, who don't know about this problem. Okay, they can understand the problem from here also. Never need to read all that stuff. Okay, let me read the problem statement for you. Find all possible L-shaped, I don't know what is this L-shaped, we will discuss. Good segments, I don't know about these good segments also. These two terms are new. In a matrix of 0 or 1. Okay, we are given a matrix of 0 or 1. We need to find some all possible L-shaped good segments. I don't know what these are, I will discuss. But I know one thing, I have a matrix of 0 and 1. See, this is the example. I have a matrix of 0 and 1. This is given to us. Okay, and I need to find out these two different things. I don't know what are these. Let's see first what is good segment here. A good segment is a sequence of consecutive ones in the same row or same column. Consecutive ones. Okay, this is a segment, good segment. This is also a good segment. Consecutive ones in the same row or maybe in the same column also. This is also, this one, this is also a good segment. All ones in the same column. Oh sorry, this is row and this is column. Okay, so you can make many actually. You can make many. This is also a good segment. This is also a good segment. This is also a good segment. This is also any consecutive ones in the same row or in the same column is known as a good segment. Okay, one term is clear. What about, we need to find out all possible L shaped. We need to actually find out the L shapes of good segments. L shapes of good segment. For example, Okay, this is one L shape. See, L shape of good segment. So this is a good segment, this one, this is a good segment, this is a good segment, and another good segment is this one, another good segment is this one, and I am making a L by using these two good segments. So I need to find out all possible L shaped good segments in this matrix, in a matrix given to us. Okay. Okay, let's see more about the L shape. Actually, to set the L shape, how I set this L shape, we need to go through the property of L shape, which is given in the question itself. I am sharing the properties of L shaped good segments. First property is each of the segment must be good segment. So in the L shape, actually I will use two segments. I will use two segments, two good segments. I will use two good segments. Good segments means which have consecutive ones, not zero, consecutive ones. So each of the segment must be L shape have two segments, two good segments actually. Okay. Another property is two segments must be perpendicular to each other. See, this is one segment and this is another one. These are perpendicular to each other. See. So the segments, good segment must be perpendicular to each other. So this is the property of L shaped. What we need to find out? I need to find out the all possible L shaped, which are made up of good segments actually. Okay, let me see third property of the good segment, L shaped good segment. The segment must share one cell, that is endpoint of both segments. Yes, these two segments must share one cell. Actually, this is the shared cell, this one, this is the shared cell. They must share, these two segments must share one cell. Okay, which is the end of both these segments. This is the end of this segment, and this is the end of this segment also actually. Okay, so next property is segments must have length at least 2. Okay, here this segment is having 2 length, this segment is having 4 length. So okay, that is satisfying this property. Let me violate this property. Let me rub the board and violate this property. Fourth one. Is this is a good segment? Is this is a L shape? This one. In this we have two segments. One is this and one is this. Okay, I have two segments. Is this L shape is satisfying this property or not? No, this L shape is not satisfying this property. Must have length of at least. Okay, sorry. This is satisfying this property. This L is satisfying this property, but not this one. This property is violated by this L shape. Yes, this property is satisfied. We have two at least 2 length. So this segment is also having 2 length. This segment is having 2 length. So this property is okay for this L. But this L is not satisfying this fifth property. Let me see what this property is. The length of the longer segment is twice the length of the shorter segment. So actually here both the segment have the same length. So one must be longer segment and one must be smaller segment. And the longer segment, let's suppose the longer segment is having X length and shorter segment is having Y length. Then the length of the longer segment must be greater than equal to 2 into Y. This is what this statement is saying. But this condition is not satisfying here, because here the length is same. Same length is not satisfying this property. Okay, so this L shape will not be considered. Okay, let me take more examples to understand the problem. You people please tell me, according to previous properties, these properties what are the valid shapes here and what are the invalid shape. 1, 2, 3, 4, 5, 6. We have 6 shapes here. Who are beginner, who are first time here, and who already know the solution, they can also share with for your friends, for the beginner who have joined this. So, okay, just simply try it. Which are the valid and invalid L shapes out of these 6? Please write in the chat. Anybody please write in the chat. Anybody please share it so that other people can, and if you know this thing, please share it. If you even don't know, please try it and try to find out, okay, which are the valid L shape. Is this the L shape? This looks like L shape. One thing is clear, this is also a L. Okay, but is this satisfying? Is this satisfying all the property of L shape or not? What I have discussed. So, one property was last property which I discussed with you actually. One thing is that so these are actually these all having 1, okay, and which are not dark, these are 0, okay, which are dark that are 1, which are not dark that are 0. So, here, so these are good segments, okay, these are good segments, and they are perpendicular to each other also. And the third property is they are having end point. Let me see. Yes, this is the common cell for this segment and this segment, which is the end point of both these segments. So, this property is satisfied, and segment must have at least length 2. So, this property is also satisfied. This segment is having 3 length, this is having 1, 2, 3, 4, 5, 6 length. So, this is also satisfying fourth property. What about fifth one? The length of the longer segment is twice the length of the shorter segment. Okay, many people have given the answer. 1, 2, 3, 6 is valid. 1, 2, 3, 6. Okay, I will come to that. Let me finish this first. So, here last property I need to check. So, smaller segment and bigger segment is this. This is smaller one, this is bigger one. So, bigger segment should be having double the length of this smaller segment. So, this is having 3 length and this is having 6 length. So, this is satisfying fifth property also. So, this is the L shape we are searching for, yes, and this is also satisfying. Actually, let me take the solution of one of you. 1, 2, 3, 6, last one I am taking. 1 is valid, 2 is valid, 3 is valid and 6 is valid. Okay, that is right. Is that valid? Okay, we need to check this one. Anybody please tell me, is this valid? Is this satisfying? Is this satisfying fifth property? This property, the length of the longer segment is twice the length of shorter segment. Is this property is satisfied by this L? The length of the longer segment is twice the length of shorter segment. The shorter segment is having 2 length, but the longer segment is having 1, 2, 3, 4, 5 length. So, that is not twice. Twice will be 4, up to 4. This can be valid up to here. Up to here this can be valid L, but not up to here. So, this is not valid. Yes, these are valid. These three are valid. Okay, these are the correct L shapes and these are incorrect L shapes. Okay, this we know why incorrect. Why this one? Because the length of this segment and this segment is same, violating fifth property. That must be double. One segment must be having double length. Why this one? this is, they are sharing this cell, they are sharing this segment and this segment are sharing this cell, but this cell is not the end point. That should be the end point of both the segments. See, that should be the end point of both the segments. This is the property. So this is not the end point of this segment or this segment. This is the end point for this segment. This is the end point for this segment. So this is also not valid, that's why. And this is valid because satisfying fifth property, satisfying actually every property. You can check. Okay, let's move on. Okay, let's now apply various approaches to solve this problem. First solution, I am sharing first solution, I am using brute force approach. So in the first step is to find out that this statement is saying that to find out that whether how many L shapes are possible at end points that need to be checked with this condition. Actually, we know this condition. We need to check this condition, and we need to verify other some more conditions also. This one is the most important one. That's why I write here. So we need to check this condition at a end point. Okay, if that is satisfying or not, and so this is the second point, and this is the third one actually. Okay, this is the second one, this is the third one. These are the two important one actually in this brute force. Let me explain these 2 points here itself in the matrix, how brute force is working. That's it. First, this one, see, first need to iterate all the possible subsegments in L-shaped segment, and secondly consider all cells in the matrix as endpoints. Okay, let me start from here, from third point. According to third point, all the cells in the matrix in the brute force, we are considering that that is the end point. This is the end point. I am just thinking that I'm considering that this is the end point. Now I will check how many L I can make from here. I will check this condition and I will apply this condition also. I will explain this condition just after a minute. But before that, I'm taking this third step. I'm considering every cell. First, I take this cell as end, considering that as this is the end point of two segments. I'm just considering that, and I'm thinking that let me check how many by using this condition. I'm checking how many L shapes can be made for this end point, then for this one, then for this one, then for this one, for all of them actually I'm doing in this step. In the second one actually what we are doing is, let me tell you, let me rub the board. In this step, I'm talking about this step, this second step, this is third one. Let's suppose this is the end point now. We have taken this is as the end point. So I need to how I am approaching here is, first I will consider that this is my one segment and this is my another segment. Now I am checking whether this is the right L or not. You can see this is not right L. You can check this with this condition actually. This is not, one segment is not the double of other. Then I will check, see, I will take this segment, I will keep this segment as it is, and while I will increase here one cell. Then I will check again now for this cell. I will check for this cell. Is this satisfying this condition? No. Here is 2, here is 3. Now I will increase this one again. Okay. So this is another L. See, I'm keeping this cell constant. I'm fixing this cell in one segment and increasing these cells in the other segment actually. So this I'm checking for this cell now. Is this satisfying this condition? Yes, this is satisfying. Then for this one, is this satisfying? No. Is this satisfying? No. Now after that I will take one more here, 3. Let me rub. Now I will increase one cell here in this segment, and again we'll start like same way. Is this satisfying? Is this satisfying? Again, is this satisfying? Is this satisfying? Again I will increase this one, then again I will start from here. So this is how actually brute force approach is working. Okay, can you people tell me, this is actually second step I am explaining to you, and in the third step, this is third, this is second. In the second step, this was the second step, and this is the third step. Can you people tell me, okay, this is the first one. Can you people tell me how much time this process will take? I am taking one cell, I am checking for all. I am taking another one, again I am checking for all. I am taking another one, again I am checking for 4. Now I will do for this also, for another cell. So I will do the same thing. So how much time this process will take, this statement will take to execute? Let's suppose the matrix size is R into C, number of row and number of column. So how many time this statement will execute? Anybody? Second statement will execute. How many time? I explained you. I fix one cell and check for all. Again I fix another cell, I check for all. I fix another cell, I check for all. Anybody please tell me. Anybody please tell me what how many times this statement will execute? I am not able to see the live chat. Let me refresh it. Okay. So somebody, what is this, row into column? Row into column, yes. That this will take this much time, order of R into C. What about this step now? How many time this step will take? I am doing this step for all the cells in the matrix. Third step, for third step. Second step, the complexity is R into C. For the third step, how much will be the complexity? Again that will be R into C, because you are checking every cell you are checking, and the size is R into C itself. So these two steps are repeating again and again. So the complexity, what will be the total complexity of this brute force approach? Anybody please tell me. This step will take order of 1 time. This will take constant time to execute. Please tell me what will be the complexity of this. Yes, R into C again, and what will be the complexity of total algorithm now? This is taking RC, this is taking RC, R into C, and these steps are again repeating again and again, these are repeating. So what will be the complexity? So that will be okay, let me share with you. That will be R square into C square, or you can say okay R into C square, anything you can say, okay, same thing. So this is the complexity of brute force approach. One more point I want to share with you. If you will check the test cases on the Kickstart page, so if you are using this approach, then your second test case will fail, because that have a timeout, that have a time limit. So this approach cannot be passed with the second test. This approach will pass the test 1. Test 1 will be passed by this approach, but not test 2. Okay, so let's take another solution for the same problem. We need to analyze these problems. Actually, we know these problems. If you know these problems, again you need to analyze them. You need to think, okay, how better you can make them. Okay, so let's look at the second solution. Why test set 2 will be fail? Actually, if we are using brute force, we cannot iterate over all possible endpoints for test case 2, as the solution will time out. We have already discussed, because that will time out. Okay, so that's why test 2 will not pass. And what is the solution for that? What is the solution? What we can improve is actually we can improve the second step. We can improve the second step. In the second step, you are unnecessarily repeating the same thing again and again. That thing we will remove here. Okay, we will quickly calculate the L shapes. There we were not quickly calculating the L shapes, but here somehow, I don't know how, we will calculate the L shapes quickly. But there I was taking order of R into C time in the second step, but here I will take less time. Okay, how in the second solution we will see that thing. Okay, but this is what we are going to do now. In the second solution, we are going to improve our second step of brute force. Okay, and we can iterate over each cell of the matrix only once and could calculate our answer. This is how we will solve second. We will go for second solution. We can safely ignore those cells that have 0. Earlier we were considering 0 cell also as an end point. How 0 cell can be the end point? We were considering all the cells as an end point, but here we can ignore the cells which having 0 value, because 0 value cannot be the end point, cannot be part of the L shape. Okay, because that is not a part of a good segment. So here we can remove in the second solution. Actually, we are going to use this concept. Prefix sum matrix can be used for fast calculation of L shapes. We are going to use this concept to improve our solution. This will help to improve the second step. We never need to repeat the things again and again by using this prefix sum matrix. I will explain this thing on the next slide. Okay, here itself I will cover that part. Let me see the approach of the second solution first. The first step is to solve the problem. See, we need to make different L's. This one, this is L, this is L. Okay, I have made 4 L's here. This is a point. This is the end point. This is the end point of 2 segments, and this is the up segment. This is the left segment. Maybe L can be like this also, like this also, like this also. For this one, this is the end point, end cell end point, and this will be at the right side. This segment is at the right side, and one segment is at the up side. One segment is at the left side here, one is downside. One is downside and one is right side. See, we have 4 segments here. Actually, we have 8 different way of representing the L. Actually, we can make another 8 from here itself. How? See, that is written here. Other 4 can be drawn by increasing and decreasing the length of the segments. Let's suppose, let me make another segment from here, from this shape. From this shape, I am making another shape by increasing and decreasing the length of these 2 segments. Here, the length of this upper segment is longer than the left segment, and now I will reverse. I will increase the length of left segment more and upper segment is less. So this is another L, just by increasing or decreasing the length size. For this also I can make another shape. I can increase the length of right segment and decrease the length of upper segment for this, and I can increase this one left segment but reduce the size of down segment. What about this one? I can increase this one and decrease this one. So 1, 2, 3, 4 and 4, 8 different ways that we can represent the L shapes actually. Okay, so this is we are going to find out these different we need to find out, okay, these different shapes, and we are going to use the prefix sum. We will calculate prefix sum of rows and columns, help in finding the length of the segment in order of 1 time actually. we will use this prefix sum. What this prefix sum is actually, see, that will be clear from here. Let us suppose this is our matrix. Okay, I am taking very simple matrix in which we have only one row. Okay, so if I want to find out the prefix sum of this matrix, then the prefix sum will be 1, and 1 plus 1 2, 2 plus 1 3, and after that we have 0. So I will be having 0. After that I have 1, then 1 plus 1 2. So I am just simply summing up different numbers. So here is I have 1, up to here I have 2, up to here I have 3 length segment. Actually this is 3 length segment. Now this is not part of segment, then that will be 0. This can be a segment which is having length 1, and this can be a segment which is having length 2. So after looking at this value, I can say that there is a segment at the left hand side which is having length 2. After looking at this value, actually I can say that I have a segment which is having a length 3. Okay, so directly after looking at this, I can find out the length of the segment. If I can find out the length of the segment, then I can find out, okay, in constant time, actually I can find out okay, how many L shapes will be possible at this point. How many L shapes will be possible at any particular point in the matrix. I can find out that in order of one time. Okay, but only thing I need to do is I need to calculate this prefix matrix, and to calculate this prefix matrix, the complexity will be R into C. R into C is the number of elements. So number of elements in the matrix. So this time complexity will be taken to develop a prefix matrix sum. This sum is helping us, this sum will help us to find out the length of the segment. See, I can find out the length of this segment 3 after looking at here itself in constant time, I can say. And this length will help again to find out, okay, how many L's I can generate from this point actually, from this point in the matrix, how many L I can generate in constant time itself. Okay, earlier I was taking R into C time, but here I can find out that thing in constant time. Okay, let's move on. Okay, third thing you need to do is actually, you need to calculate the prefix sum matrix. For example, I have this matrix, this is our input matrix, and we need to calculate actually 4 type of prefix sum matrix. One is right matrix, one is left, one is up, one is down. This will keep record of right prefix sum, this will keep record of left prefix sum, this will keep record of up prefix sum, this will keep record of down prefix sum. Okay, you can see here what is the okay, I am just asking to you, if for this cell, I am talking about this cell, for this cell, if I want to find out, okay, what is the prefix sum for this cell, if I am checking from this to this side, I am calculating the sum from left side actually. Okay, so from the left side, if I am checking, so the sum will be 1 2 3. Okay, so that will be actually my left prefix matrix. So how I will make the right prefix matrix? So let's suppose I am here and I want to find out, okay, how many what is the size of the segment at the right hand side. The size of the segment including this cell will be 2 actually. Okay, so I can count like this, 1 and 2. Okay, so that is my right segment prefix sum matrix. Okay, let me calculate them, all of them actually. First of all, from this I am going to calculate the right prefix sum matrix. So here I have 1. Okay, let me okay, here we will get 1. Okay, so if you will actually if you will see here, I think here is 0, 1 2 and 1 2. Okay, let me check for this cell, this one 1 2 3, you are getting 3. Okay, at the right hand side always check for the right, from the right to left, add from right to left, simple. 0 0, I think this will be 0. So 0 0, after that I get 1. Okay, for this cell, right to left, add right from right to left, this from this side to this side. Okay, so 1, and after that you get again 1, so that will be 2, again you get 1, you get 3. So I can say that, okay, I can say that after being at this cell, I can say that I have a segment which is having length 3. I have a good segment which is having a length 3. See, we have a good segment which is having length 3. Just looking at this 3 at the right hand side, actually at the right hand side. Similarly for this is 1, this will be 2, 1 plus 1 2, again I get 0, 0 will be remain as it is. For this is 1, this is 2, 1 plus 1 2 and 0 as it is. Let's check for this one. This will from left to right, sum from left to right, 1 as it is, 0 as it is, 0 as it is. So this will be 1 2 3, 1 2 3, this will be 0 1 2, 0 1 2, 0 1 2, 0 1 2. Okay, upside, from bottom to upside. Okay, is that bottom from, no, okay, from top to bottom actually. Okay, 1 2, 1 2 0 0, 1 2 0 0, 0 1 2 3, 0 1 2 3, 0 1 2 3, 0 1 2 3. Okay, from downside now, from downside, 0 0 1 2, 0 0 1 2, 1 2 3 1 2 3 0, 1 2 3 0 and so on. Okay, so we need to make these 4 prefix matrix. Okay, so these prefix matrix actually will help us to find out. Okay, one thing is that, okay, after being at this cell, I can say that I have a segment at the right hand side. I can say that I have a segment which is having length 3. I can find out this information in constant time, and this will also help me to find out all the else which I can generate by assuming that this is the end point in constant time. In constant time I can find out all else which is having this end point. Actually for every cell I can do this by using this prefix matrix. How? Let me show you. Okay, let me show you by using 4th point. Okay, calculating number of possible L-shape good segment on the end point. Okay, I will use this formula actually. I will explain, okay, how this is working. First I will directly apply this formula on any cell, and I will show you, okay, I will show you how many actually L you can make from that cell, how many L you can make from that cell. So for example, okay, let me show you here. See, from you can see here is one L. Let's suppose this is 1. Let's suppose actually in this example maybe we do not have the L. Okay, let's suppose this is 1 and this is L. Okay, this will satisfy all the property now. If let's suppose this is 1. Okay, so let me apply this formula. Let me apply this formula here. Can I find out all the L's which can be generated from here? So y is the length of the bigger segment, so y value is 4 here. Okay, if that will be that will be 4 actually, so we could get this value from here, but right now that is 0, so that's why that is showing 0. We can directly get this value 4 value from here, and after that we need to divide that with 2. I'm just simply applying this formula using these matrix, getting this data directly from these prefix matrix, and this formula will give me all the possible L shapes Okay, will give me all the possible L shapes actually. So what is x here? The value of x is 2, which I can, okay, I am going from, first I was going from, see, I am making this L, I am making this L, okay. So I am making this L, this is the common cell. Now I get this value for y, and I get x value actually from this side, okay, 2, I get 2. So which one is I need to find the minimum of them. Y value is 4 divided by 2 and 2, and which one is minimum? 2 is minimum, actually both are same, and we need to minus 1 also. So I am performing minus 1, so I am getting 1. So how many L I can make here? You can see directly here also. I can make from these two segments, from this segment and from this segment, I can make only 1 L. I can make only 1 L. I cannot make more than 1 L from here. There is no sub L here actually, like this. This is not the L. This L is not satisfying all the property actually, because one segment must be double the size of the another segment. So that we are directly getting, okay, how many L we can make if we have this point as our, this point is our end point. Directly we are calculating this value. So this will take order of 1 time to find out by using these metrics actually. Okay, let's move on. And after calculating, okay, L shapes, all the 8 L shapes actually, we need to just add the count. Okay, maybe I am making like this, I can make like this also, and I make like this also, I make like this also. All the 8 shapes which I discussed with you earlier, these 8 shapes, let me show you all the, okay, in the previous slide, all the 8 shapes which I show you, for a particular point I need to count them, I need to add them, and then I will get all the L shaped, possible L shape on this point, okay. And I need to do it for, actually I need to do it for all the cells, okay. I need to do this operation, we need to perform this operation for all the cells. So on one cell that will take order of 1 time, and if we are performing on, actually on R into C cells, then what will be the complexity? Please, okay, you people please tell me the complexity of this approach, second approach. I have summarized this algorithm with these 3 statements. You can read these 3 statements and please share the share, okay, what will be the complexity of this solution. If you, okay, if you even do not understand what I tell you, okay, you simply just go through these 3 points. This is what actually the second algorithm is, second solution is. I again summarize that. You go through these 3 points and just try to find out the time complexity. This is, I just summarize everything. Order of row into column, R into C, okay, let me show you, R into C, okay, sorry, C is here, row into column, okay. So how that is coming? Let's generate the same complexity from here also, from these statements. So how our algorithm is working? We will recap whatever we have done here, okay, and we will see how we are getting this complexity. So we constructed 4 prefix matrices. We know this thing. We construct 4 right prefix matrix. We construct left, up, and down, okay. So what will be the time complexity for all to construct all these prefix matrices? I have tell you that, okay, the time complexity to construct one prefix sum matrix is R into C, and for 4 that will be into 4, okay. So this is the time complexity for first step. What is the for second one? See, this I have already explained, this will take constant time, okay, and you need to add all L shape segments to, if you are getting if you are adding all L segments, so 8 operations you need to perform, which is again constant, so total complexity is actually order of R into C for this algorithm. Okay, let's move on. Okay, let's see now the code for L shape plots. Actually, I have just summarized the code also here. Whatever we have done, I am showing the code for that, very specific code, so that we can focus on that. We are again I am doing the same thing. We are finding prefix sum in these 4 matrices. So for that purpose, I need to write these line of code. So see, what first line of code is doing. This is my left matrix. Okay, so if I want to find the sum from the left side actually, okay, from the left side, I need to find out the sum. Should I take the example 1 1 1 1? Okay, let's put here I am, and I want to find the sum. Here I need to find the sum. Then see, this is row, this is column. Okay, this part is column, this is row. So row will remain same, and column is changing, column is decreasing, this and this, down, going downside, and I am incrementing. I am adding this one and this one with this one, so I will get 4 here. So I am reducing the column. See, you can see column 1 1 1 1. Okay, so from this way I get value here. So this is how I am building this left matrix. And what about up matrix? So I am let me take this example 0 1 1 1. So see, in this I'm changing row. This is row 1, row 2, row 3, row 4. So I am changing the row. See, I am changing the row, and column is fixed, and I am adding all the values. So this will be 3. Okay, so this is how I am making up matrix, and the similar I am making right one. In the right you can see I am moving this side, so I am increasing the column. In downside, if I am going downside, so I am increasing the row, I am moving this side, so I am increasing the row, column is same. Okay, this is how we are calculating prefix sum of various 4 matrices. This is the main code I am sharing with you actually. Okay, and what other operation we are performing is, we are doing this thing, we are calculating this thing. So actually in code you can write like this. See, what you need to do is, you need to pick the data from these matrices. How you will pick? For example, for this, actually let's suppose this is your endpoint. Okay, and this is the up segment, this is the right segment. Okay, and in this case we are assuming that okay, the right segment is bigger. Okay, this one is bigger, which is I am dividing with 2, and this is the smaller segment, this is the bigger segment. So in this segment, for this segment actually I am calculating this value. Okay, for this L. Actually I need to perform this operation for all shapes actually. See, this is the another shape. In this I am going up and left is bigger. You can draw like this here. Okay, and in this I'm here, I'm going down, and I'm going right. Okay, I'm going down and I'm going right. Here I'm going down, I'm going left. Okay, similarly there are another 4 L shapes which we can generate here, and from there I can calculate, okay, at particular point I can calculate how many L's I am making of this type. From this statement I am checking how many L's I am making. Maybe this is 1 L, and maybe this is another L. How? Because this L may be having maybe of 2 into 4 size, and this L may be having 3 into 6 size, and the another can be, okay, 4 into 8, okay, double. One is double and one is 4, okay. So I can have 3 L's from here for this, from this point. So I can calculate with this statement. Similarly, for other type of L, I am using different statements, and this formula is helping me to calculate all the L's at a particular point, okay, in constant time. Okay, let's move on. This is the main code. You can see the same thing actually on the Kickstart website also. I can show you the same thing here. The same code. I just copied all these things actually. You can see this statement I copied, and after that this up, then right. These are all operations you are performing, then down, okay, and you are performing these operations. Okay, I just mentioned all these operations. You can go through the code, you can pick any code actually. I just pick the code which is easy to explain to you people. Okay, this is the main how the code this is the main code for this problem. Let's move on. Okay, let's take the third problem from the round A. Okay, what is the problem? Please read the problem. Okay, this is the problem. Again, you can go to the Kickstart website actually. You can see the problem there also, this problem, rabbit house problem, and you can find the problem statement here, the big problem statement. Again, I have just reduced this big problem statement for you people in only one line actually. So if you will read this statement, this is what actually they are asking in that much big story. Okay, what this statement is, what this problem is, problem statement, let me read. Convert the given 2D matrix. They have given us a 2D matrix. We need to convert that 2D matrix in a format such that this condition satisfied. We need to just convert a matrix, 2D matrix, in some format based upon this condition, where x and y are adjacent cell. Here x and y are adjacent cell. We need to modify the matrix, 2D matrix, based upon this condition only. That's it. This is what they are asking actually. And what this condition is actually, I'm taking x and y are adjacent cells. Let's suppose, and let me take an example. So according to this, the absolute difference, this is absolute function, absolute difference of the value at x cell. Let's suppose this is x, if this is x and this is y, and I am talking about this cell, let's suppose. So this cell, x and y are two adjacent cell. Okay, sorry, this is x cell and this is y. X and y are adjacent cells. Sorry, x and y are adjacent cell. Okay, and I need to check this condition. What this condition is saying, the value at x, which is 5 in this example, and value at y, which is 4, the difference of them must be less than equal to 1. So this condition is actually satisfying here. 5 minus 4 is actually 1. Yes, that is equal to 1, and that can be less than 1 also. actually that the difference should not be in minus. Okay, that should not be in minus. Okay, okay. So here this condition is not satisfying here. This condition is not satisfying here. Let's suppose this is x, this is y. So x is 9 and y is 1. We are assuming that there is no negative value here. So 9 minus 1 is 8. So this condition is not satisfied here. Okay. So we need to satisfy this condition. We need to satisfy this condition. What this condition is? Let me tell you. The absolute difference of two cells must be either 1 or 0. That's it. That must be either 1 or 0. That's it. Okay. So absolute difference of two adjacent cells. Adjacent. Okay. These are. So what are the adjacent cell of 5? Adjacent cell of 5 is this, this and this. So absolute difference of 5 and 4 is 1. That's fine. This and this is also 1, fine. This and this is not 1. So if that is not 1, what I need to do is actually I need to increase this value. If I increase this value to up to 4, then the difference will become absolutely 1. Okay. So I need to increase this value actually. So that the condition can be satisfied. So I need to increase this value to 1, then 2, then 3 and then 4. Okay. So the absolute difference again will be then 1. Okay. So now the condition is satisfying for all the 4 adjacent cells. Okay. So I need to increase the value of the cells. This will be more clarified from some constraints. Actually we have some constraints to solve this problem. Actually minimum number of moves are required. Here minimum number of moves I need to make. See, I can replace this 0 with 6 also. If I am replacing this with 6, then the absolute difference again will be 1. 6 minus 5 is 1. Absolute difference will be 1. Again that will be 1. But I need to perform minimum number of moves. I need to increase this value minimum number of times. So rather than increasing 0 to up to 6, it's better to replace 0 with 4, because to replace 0 with 4, number of moves are less, number of moves are 4 only. In the case of 6, number of moves are 6. So I need to use minimum number of moves to satisfy this condition. Okay. Okay. And the second one is already available values cannot be reduced. Already available values cannot be reduced, means I already have 9 here, I cannot reduce it up 8, I cannot reduce it 7, I cannot change already available values. Okay, these are the constraints for the problem. Third one is there can be 2 or more same values in the matrix. See, 9 is here also and here also. So there can be 2 or more same values in the matrix. Actually due to this constraint, actually we need to perform the logic in somewhat different way also. Okay. Okay. So this is the problem statement. I am repeating the same thing. What you need to be done is we have a 2D matrix. They provide us a 2D matrix. We need to convert it such that the difference of two adjacent cells, any two adjacent cell, can be maximum 1 and minimum 0. Okay. So if we have 9 here, so adjacent must be 8. I need to increase 6 to 8, 0 to 8, 1 to 8. Okay. I can increase it up to 10 also, but again we have one constraint. We need to perform minimum number of moves. So we need to replace with 8. Okay. So adjacent cells must having the difference of 1 or 0. That's it. Okay, that cannot be in minus. So don't take this condition, that cannot be in minus. Okay, that cannot be in minus. Okay. Let's solve this problem, and I will solve this problem without using any mean heap and max heap. Actually by using mean heap or max heap or priority queue, this problem will become easier to solve. I'm just using again brute force approach without using priority queue and max heap. Okay, because with max heap I can find out the maximum element in my matrix, and from that element I can increase the value of their adjacents. Okay, but here I am not using, I am without max heap and priority queue, I am trying to solve the problem. What I need to do, I need to convert this matrix such that every adjacent cells must have the difference of 0 or 1, that is it. This is the question. Okay, let us move on. So, the solution is, first step is find out the largest element in the matrix. So, first step I am taking, which is the largest element? 9. So, to find out the largest element, actually I will search all the elements one by one, one by one, one by one, one by one. So, this is also largest. Okay. Second step is perform add operation on the adjacent elements to make them size of x minus 1. Let us suppose the size of the largest element is x, then according to second step we can perform add operations. We cannot perform delete operation, we can perform add operation, so that adjacent elements, what are the adjacent of 9? This and this, this and this. Adjacent element must have the size of x minus 1. If this is having 9, this should have 8. So, I will replace this with 8 with 8 with 8. Similarly, for this one also with 8, sorry, this is not adjacent, this is adjacent, this one and this one. So, 6, 7, 8. So, how many moves I am performing? I am performing 2 moves here. For here, how many moves I am taking? I am taking 8 moves. For here, to make it 8, how many moves I am taking? 7 move. 7 move you can say, or you can say 7 add operations. So, how many total operations you are taking for this cell, particular this cell? 8 plus 2, 10 plus 7, 17 move operations or add operation you are performing to satisfy this cell, to satisfy the condition that okay, the adjacent cells must have, this is the adjacent, this is the adjacent and this is the adjacent. Adjacent cells must have the difference of either 1 or 0. Okay. So, minimum operations I need to perform here is 17. What about this? Here 8 move I am performing, here 7, 1 is already there, here also 7. Okay. So, 14 plus 8 is 22. So, here I am performing 22 operations, move operation you can say, add operations to satisfy this cell. Okay. Okay. So, you need to do this for, actually you need to further do the same thing for the second largest element of the second or next largest element also. So, after doing for this, we need to perform the same operation for the second largest one. Now, 8 will be the second largest one. So, for all these 8s we need to perform this operation for all these 8, because 8 is the second largest. What we need to do is check out their adjacent. Let us suppose for this 8, adjacent is this and this cell. So, I need to increase it up to 7, this is up to 7, this is up to 7. So, how many move I am taking? For this I am taking 6 move, from this I am taking 3 move, from this I am taking 7. So, 7 plus 3, 10 plus 16 moves I need to take to satisfy this cell. Similarly, for all the 8, and then I need to repeat this step again. Okay. What about this third step? In third step, actually I am removing this 9. If for 9 actually I have already performed the operation, now we can remove the 9, we can remove the 9. Similarly, if I have performed the operation for this 8, then we can remove this 8 after incrementing its adjacent. Okay, after adding value to their adjacent, I can remove this, because this is satisfied with their adjacent. Okay. Okay. So, this is how actually this algorithm will work. This is again a brute force approach. We are not actually using here any priority queue and max heap. We are going every time I am going to every time first I find out the maximum element, largest element. Okay, to find the largest element, how much time that will be taken? That will be R into C every time for a largest element. For finding the largest element, I need to go through all the cells. Okay, and then I will perform the add operation. Okay, I need to perform the add operation, and this add operation I need to perform one by one. So you need to replace this 1 with 2, then 3, then 4, and so on. Let me rub this board. So first you need to find out the largest, so that will take order of n minus n into C. Okay, so n is the number of rows, or you can say R into C. Okay, and after that you need to perform the add operations on the adjacent elements. So you need to perform add operation. What I am saying is that this is the adjacent, this is the adjacent, this is the adjacent, one by one. First this will replace with 1, then 2, then 3, then 4. So how many move operations you need to perform? 8. Up to 8 you need to go. You cannot replace it directly with 8. So this will be count. You can say this will be count as 8 move operations, 8 add operations. Okay, not 1. Directly we cannot replace with 8 0. Okay. Okay, let me find out the complexity in the next slide itself. For that, first you people tell me the searching time of one element. Actually, I have already shared. What is the searching time of one element? So, okay, let me tell you. The searching time of one element is R into C, row into column. Every time I need to go through all the elements. If to search one element, this much time is taken. So if we need to perform the same operation on R into C elements, we need to perform the same operation. We need to find the second largest, then third largest, then fourth largest, and the fifth largest. In the worst case, I need to go for the all elements. Okay, so the complexity will be this into again R into C. So the complexity for this approach will be this R into C into R into C. So this time is taken to find out one largest element, and this time is we need to perform this operation on all the cells on all the cells actually. So all cells are R into C, so total is R into C square. R is the row, C is the column. This is the complexity of this solution. Let's move to the next solution. Second solution for rabbit house problem. So actually the algorithm is same which I used earlier, but now I am using max heap or priority queue. Anything you can use. So what is the use of benefit of using max heap and priority queue? If I am using max heap, then let's suppose I am using max heap, then finding the maximum element will take order of 1 time. If I want to delete the element, I want to remove that element, then to find that element, that will take constant time. And to remove that element, that will take actually log n time. N here is actually R into C. Number of elements are R into C. So log of R into C. This much time will be taken to delete that element. Okay. So, and we need to go through all the elements actually. We need to go through all the elements. So the complexity will be, we need to go through all the elements in this case also. To go through all the elements, the complexity will be R into C. So the total complexity will be R into C into log R into C. So the algorithm is same, just I am using max heap or priority queue here. See, there are two important points to share with you. One is priority queue or max heap can be used to reduce the time complexity. Yes, that is reducing the time complexity. We will talk about it in next slide more. Adjacent cells are already satisfying this condition. If adjacent cells are satisfying this condition, already satisfying, we never need to perform any operation actually. Okay, here we never need to perform any operation. So this is the second solution. Same approach I am using, simple, just I am using min max heap or the priority queue. That is helping me to reduce the complexity to, let me show you what will be the complexity. Now searching an element will be, okay, order of 1, and if you want to delete the element, so that will be take order of R into C. Okay. So what will be the complexity, and you need to do it for all the elements. All elements is R into C again. Sorry, this will be log n, log of R into C. Log of R into C will be the time taken to delete one element, and this is the operation we need to perform on all the elements. So the complexity will be R into C into log R into C for the second. If I am using simple, if I am using the max heap or the priority queue. Okay, let's move on. Let's check the third solution for the same problem. Now, actually I am doing the same thing, but I am using list of buckets. In case of in place of max heap, I am using list of buckets. If I am using list of buckets, then okay, I am replacing the priority queue with the list of buckets. If I am using list of buckets, then the complexity of insertion and removal can be reduced to order of 1. If that is reduced to order of 1, insertion and removal, the delete operation I can perform in order of 1. Again I need to go through all the elements, but every time for each element the complexity will be order of 1. So what will be the total complexity for this case? Iterating over the bucket is linear in the number of buckets. So that will be this step will take R into C, this step is taking order of 1, total is multiplying these two. So the complexity will be R into C. We have reduced further by using the list of buckets. Okay, so let's check out the code for the rabbit house. Again I have taken the main code which is working behind this problem, and we know about this actually. How we know about this? We are checking actually, first we are searching for the largest element, we will search that is above code, we will search that element. After that we are looking for the second largest element, we are checking for the second. If largest element is 9, second largest is 8 actually, third largest will be 7. So that will reduce 1 only, that will reduce by 1 only. So this is the code for the second largest element. Okay, so the value will be maximum value minus 1. Okay, and this and then what you need to do is, if that value, you are checking whole grid, this is the complete grid, this is the complete table you are going to check. This is your grid or table. I am giving that, I have given the name grid here. So if this value, this value is not same as this value, then we will move on, we will continue, we will move on, we will move on, we will move on. If we will get 8, second largest here, then we will replace its adjacent, 4 adjacent we will. What we are doing actually is, we are adding the what we are doing here is, for this location, see I plus 1 and j. So I plus 1 is this, I plus 1 and j is this. If this is row, let's suppose this is row and this is column, then I plus j will be this is row, and row incrementing, and column is this j. So I am talking about this cell in this statement. Okay. Okay. So here we need to perform the operation. After that here, after that here, after that here. So at these places we need to perform the operation. And you can check out the actual code, complete code also. The same thing is happening here. I do not have a solution for this. Okay, so this is the code. Okay, you can find out the other codes that will work in the same way. Okay, that's it for today. Best of luck for your Google Kickstart round, next round. You people can join us if you want to learn about. You want to take a course on competitive programming that is provided by Joseph Amrit Raj, that is the Grand Master. Actually, you can check out the below link given in this video, or you can go to the website of Geeks for Geeks if you want to join this course. This course is given in very detail from starting, means from if you are a beginner, then you can start from there also, and if you are in advanced level, that will help there also. Okay, and Joseph have very great rich experience to solving these competitive programming problems that will take your problems and give solutions to you. Okay, and you can directly connect with him. So if you want to know about this course, you can check out the below link, or you can go to our website. Okay, best of luck for your Kickstart round, next Kickstart round. Okay, thank you.